So if you simplify this Laplace transform equation, we found tau s v0 by s plus v0 by s, that is equal to k tau into s x0. S already we have mentioned that the initial conditions are assumed to be 0. So above equation can be simplified as v out of s equal to 1 plus st, that is equal to k tau into s into x of s. So we are interested in the transfer function. Transfer function is nothing but the output in s domain divided by input in x domain. So if you just keep these term, I mean v out of s and x of s in one side and moving all of the time to the other side, so we'll have kt of s, kt s divided by 1 plus st or s tau. So the transfer function become, if you just substitute s equal to j omega k tau divided by 1 plus j omega tau. So now this is the equation we have already obtained, v out of s divided by k into xi of s. I think this k was here, so just move this k down here. So this is talking about transfer function value, I mean v out of s divided by xi of s. And there's an addition term which is the k, which is the constant. Already we have discussed that, means the sensitivity. So we get the equation j omega tau divided by 1 plus j omega tau. So it's a complex term. So if you try to find out the magnitude of it, what we found, that is the numerator will be omega tau divided by 1 plus, I mean square root of 1 plus omega square into tau square. And if you extract omega tau square from this bracket, I mean from the square root outside, then we'll have omega tau, and this omega tau and omega tau cancels. We'll get the equation 1 divided by omega tau square plus 1 under root, or 1 divided by 1 square root of 1 plus omega tau the whole square. Now let us look at, for a value of omega tau which is very high. Assume that it's a very high value, means much more higher than 1, great 1. In this case, the above equation can be approximated as that is equal to 1 and the corresponding phase angle supposed to be 0. So if you apply the same rule for the phase angle, which is tan inverse b by a minus tan inverse e by a, then we will get a phase angle is also equal to 0. So now let us assume that we are going to apply a pulse of height a to the transducer. So means what, we are going to give a pulse. So in order to reproduce the corresponding signal or the output, if you just observe the output signal, we can find that the output has got different curves depending upon the time constant. So we found that tau 1, tau 2, tau 3, these are the different time constants of the circuits. So from this graph it is clear that in order to get the or duplicate the same nature of the input, we need to have a very high value of time constant tau. So higher the time constant, then will be approximately the same response, or the same shape can be recovered. So in order to have faithful reproduction of the input displacement xi, the faithful displacement, so this is the corresponding displacement. So the value of tau should be large, and practically speaking, if you are going to maintain the overshoot and the damping factors and all within maybe 5% value, then practically the value of tau somewhere around 20 times the time duration of the pulse. So with this we conclude the portion of transducer. Thank you very much for watching.